So if you run into a conceptual series parallel DC circuit where the resistance values are increments of R, not necessarily an ohms value, having a total voltage source, in this case 12 volts, you can apply the rules of circuit analysis for DC circuits, solving the problem algebraically. So we're combining R4 and R5 in parallel, so you can just say 2R and 0.5R, so you can just treat the R as if it's ohms. So all we're doing is combining R4 and R5 in parallel, so we get 0.4R. Then we add this to R3 and R6 in series. Then we get 5.4R, and then we combine that value with R2 in parallel, so we get 1.46, and then added to R1, which is just 1R or R, so the total resistance is 2.46R. So we can get a total current from the positive terminal source of the total voltage divided by the total resistance, so 4.88 amps, which then multiplies itself times 1R, so 4.88 volts. We subtract 4.88 from 12, so 7.12 volts goes to R2, which we divide into the R value at R2, so just divide it by 2, 3.56 amps. So that steals from the 4.88 on series, leaving 1.32 to go to R3 and R6. So if we subtract those two voltage drops, R3 and R6, from 7.12, we're left with 0.52 at R4, leaving 1.06 to go on series to R5, multiplying itself times 0.5R, so just 1/100th of a volt less, but it's more or less a balanced circuit still. And then you can get the voltage values at each resistor as follows here. So if you get a problem like this that's conceptual with just R, you can kind of replace that with just ohms.